In the summer of 1348, as plague crept through Europe, a traveler entering a walled town in southern Germany would have done something that feels reckless to us today. He would have leaned over a stone well in the center of the square, lowered a wooden bucket on a hemp rope, and drunk the water. Cold, clear, and trusted. Not boiled, not filtered, not treated with chemicals. Just water drawn from the earth, the same well his grandparents had used, and their grandparents before them. This wasn't an act of desperation, it was routine. In many medieval towns, wells remained usable for centuries. Even as populations rose, animals lived nearby, and waste disposal systems were primitive by modern standards. Some of these wells, dug in the 11th or 12th century, still produce potable water today. Meanwhile, in the 21st century, cities with advanced infrastructure issue boil water advisories. Bottled water fills supermarket aisles, and contamination scandals make headlines every year. How did people with no microbiology, no chlorine, and no modern plumbing manage to keep water clean for generations? And why do we struggle to do the same? The well itself. Medieval wells were not casual holes in the ground. They were engineered structures, often the most carefully built feature of a settlement. In many towns, the well was dug first, before houses or walls, because everything else depended on it. The depth mattered. Medieval well diggers aimed to reach stable aquifers, often 10 to 30 meters below ground, sometimes deeper in chalk or limestone regions. This wasn't guesswork. Well diggers learned to read soil layers, moisture changes, and rock types. They knew that shallow groundwater was unreliable and easily contaminated, while deeper sources were filtered naturally by layers of earth and stone. The walls of these wells were lined meticulously. In stone-rich regions, dry stacked stone or mortared masonry formed a tight shaft. In sandy soils, wooden linings, often oak or elm, were used, chosen specifically for their resistance to rot when submerged. These linings prevented surface soil from collapsing inward and kept runoff from seeping directly into the water column. Contrast this with many modern groundwater systems. Today, we often rely on shallow wells, poorly sealed boreholes, or aging infrastructure, where cracks allow contaminants to enter. Medieval wells, by necessity, were built to last generations because rebuilding one was slow, dangerous, and expensive. Durability was not a bonus, it was survival. Natural filtration. The greatest water filter medieval people ever used was the ground itself. Rainwater percolating through meters of soil, sand, gravel, and rock undergoes a slow, continuous filtration process. Particles are trapped, organic matter is broken down. Many pathogens die long before the water reaches the aquifer. By the time it enters a deep well, the water has often been filtered for months or even years. Medieval communities unintentionally optimized this process. Wells were placed upslope from waste areas whenever possible. Latrines, tanneries, and animal enclosures were kept downhill or outside town walls. This wasn't germ theory, it was observation. People noticed that wells near waste tasted bad or made people sick. Over time, customs hardened into rules. Modern cities often reverse this logic. We rely on centralized treatment plants to clean water after contamination occurs, rather than preventing contamination at the source. When those systems fail, through flooding, pipe breaks, or chemical overload, the water becomes unsafe almost immediately. Medieval wells worked slowly, quietly, and constantly. They didn't need to react to contamination because they were designed to avoid it in the first place. Materials mattered more than medieval people fully understood, but they paid attention anyway. Stone wells were often lined with limestone, sandstone, or granite. These materials are not chemically inert, but that worked in the well's favor. Limestone, for example, buffers acidity. Slightly acidic water passing through limestone becomes more neutral, reducing corrosion and inhibiting certain bacteria. Wooden linings, which sound primitive, were carefully chosen. Oak contains tannins that inhibit microbial growth. Submerged oak can last centuries, as long as it remains underwater and oxygen poor. Medieval builders knew this from shipbuilding, bridge pilings, and harbor works. Modern infrastructure frequently uses concrete and steel. Concrete cracks over time, especially under chemical stress. Steel corrodes. Plastic pipes leach compounds and degrade under UV exposure. These materials are cheap and fast to install, but they are not timeless. Medieval wells were slow to build, but chemically stable once finished. Their materials interacted with water gently, not aggressively. Community rules. One of the most overlooked reasons medieval wells stayed clean is that they were socially protected. Wells were communal property, not private utilities. Everyone depended on them, so everyone had a stake in their cleanliness. Rules governed their use. In many towns, washing clothes at the well was forbidden. Animals were not allowed nearby. Buckets used for drawing water were not used for other purposes. In some regions, fines were imposed for spitting near a well or dumping waste within a certain distance. These rules appear in town charters from as early as the 12th century. In London, by the 13th century, regulations specified that no filth or dung be placed near public conduits. Modern water systems are invisible. Pipes run underground. Treatment plants sit far from daily life. Because the water source is abstract, responsibility is abstract too. When contamination occurs, blame shifts between agencies, contractors, and governments. Medieval people could see their water source every day. That visibility created accountability. Slow water speed is an enemy of cleanliness. Medieval wells worked slowly. Water entered them gradually, seeping in through stone joints or porous ground. This slow movement reduced turbulence, kept sediments settled, and limited the spread of contaminants. Modern systems prioritize speed and volume. Water is pumped aggressively, moved under pressure, and cycled rapidly. When a contaminant enters the system, it spreads fast and far. A single failure point can affect thousands of households in hours. Slow water also means stable water. Temperature remains constant, typically between 8 and 12 degrees Celsius in much of Europe. Many harmful bacteria thrive in warmer, fluctuating conditions. Medieval wells offered a cold, dark, stable environment that discouraged microbial explosions. Efficiency, in this case, traded resilience for convenience. Maintenance culture. Medieval wells were not abandoned once dug. They were maintained, inspected, and respected. Town records show regular well cleaning, sometimes annually. Sediment was removed. Linings were repaired. Buckets and ropes were replaced before failure. This work was unpleasant and dangerous, but it was prioritized. In contrast, modern infrastructure often operates until failure. Pipes installed in the mid-20th century are still in use today, long past their intended lifespan. Maintenance budgets are cut because the systems are out of sight and politically unglamorous. A medieval well failing meant immediate crisis. A modern pipe failing often means a press release and a temporary workaround, until the next failure. Pathogens and reality. It would be dishonest to claim medieval water was always safe. Waterborne diseases existed. Dysentery, typhoid, and parasites were real threats. But the risk was unevenly distributed. Deep wells in well-managed towns often produced remarkably clean water. Shallow wells, surface water, and poorly placed sources were dangerous. Medieval people learned to distinguish between them. Modern water systems promise uniform safety. But when they fail, the failure is systemic. Flint, Michigan is one example, but not an isolated one. Chemical contamination, agricultural runoff, and aging pipes create risks that medieval systems never faced. The difference is not knowledge, it is scale, complexity, and dependence on fragile systems. Urban versus rural. Interestingly, some medieval cities had cleaner water than modern rural areas. Urban wells were often deeper and more regulated. Rural households sometimes relied on shallow wells or streams, which were more vulnerable to contamination from animals. This mirrors modern patterns, where rural wells are more likely to be contaminated by nitrates or bacteria than municipal systems. However, medieval cities concentrated effort and expertise around shared resources. A well in a city square might serve hundreds of people, justifying the cost of deep digging and stone lining. Today, individual responsibility has replaced communal investment in many places, with mixed results. Forgotten design logic. Medieval wells were designed with failure in mind. Builders assumed floods, droughts, and misuse would happen. They built margins of safety. Wellheads were raised above ground to prevent runoff entry. Stone lips diverted rainwater away. Wooden covers reduced debris and animals falling in. Some wells had multiple buckets to prevent cross-contamination. Modern systems often optimize for average conditions. When extremes occur, flooding, power outages, chemical spills, the systems are brittle. Medieval design was conservative because lives depended on it immediately, not statistically. What we lost. The medieval approach to water was not romantic. It was cautious, slow, communal, and grounded in observation. People didn't trust technology to fix problems after the fact. They designed systems to avoid problems in the first place. Modern water fails not because we lack technology, but because we rely on it too much. We assume treatment can compensate for poor sourcing, poor materials, and poor maintenance. Medieval wells remind us that cleanliness begins upstream, literally and figuratively. Medieval wells stayed clean for centuries because they were deep, slow, well-placed, and socially protected. They relied on natural filtration, durable materials, visible responsibility, and continuous care. They were simple systems, but not careless ones. Modern water systems are powerful, fast, and complex. When they work, they deliver miracles. When they fail big. The lesson of medieval wells is not to abandon modern technology, but to rethink priorities: prevention over correction, durability over speed, community responsibility over distant abstraction. The stone wells still standing in European town squares are not symbols of ignorance. They are reminders that clean water is not just a technical problem. It is a design choice, a cultural value, and a long-term commitment, one we once understood very well.